All right, here we go. So if Jen is attending another music store's banjo sale, and she has this table for us, so let's go ahead and make our totals. So I see 25, 13, 25. Yikes. Good start. Please don't unsubscribe. 9, 21, 24. Might be. Grand total is 45? Let's see if I can do the counting on the other ones. Yes, 36 plus 9 is 45. Mathing is tough. Okay. Are these events independent? So I want you guys to do this the same way that you just did the one with the health insurance and the retirement plan. Okay? So remember, what is the math you're going to do? What do I want you to do first? Pick one. So which one? Oh, shoot. Right. 5 strings? A lot of students pick the first one. Do you have to pick that one? No, pick either one. I don't care. So let's find the probability that the banjo has 5 strings. So this is looking at all the banjos and how many of them have 5 strings. 13, right? Because I don't care right now about if they're 25% off, if they're half off. Just if they have 5 strings. So go ahead and write that down. Now, I'm going to copy it down. But what is my given? What does my given need to be if I chose 5 strings? 25% off. So now what that does is it changes my denominator. Now my denominator is the total from that column, 25% off, which is 21. All right, and out of that column, how many have 5 strings? 7. Are these the same? Let's see. Don't think so, but let's check. Is it almost? How almost? That's not close enough for me to say. So 0.28 repeating. And then this is 0.3 repeating. Yeah, that's not close enough for me. So I'm going to say they are not independent. So I believe on this, you're just going to click no. Go ahead. How close do they need to be? Yeah. Honestly, for me personally, I say on this link, they need to be exactly the same. So for this assignment, they're not equal, you put no. But for my, in life, when I'm doing this, if they're within a percentage, like if it was 29% and 30%, I'd say that's close enough. They're independent. That's just my rule. Now, again, you're going to see context is everything, right? If you're talking about the context of talking about parts that are going into assembling, bless you, assembling like an airplane that passengers are going to be on, well, then I care more about it actually being true, right? Because we're talking about lives are at stake. But just in general, 1% is fine. Go ahead, Nate. Okay. Number 2. We have Regan is trying on glasses, tired of squinting while driving. That's the worst. Let's get some totals. So I have 14, 16, 20, and 2. What's that? 13, 25, 26, 17, plus 9. Is that also 26? Oh my. Is it 25? Isn't it 9 plus 9 plus 8? 18 plus 8 is 26? Okay, cool. Grand total? 52. We don't need to get mad about this. We're all good. Okay, pick one. Do you want to pick the pair of sunglasses have regular lenses or the pair of sunglasses have round frames? Oh, you guys didn't want to mix it up? All right, fine. Okay, so we have 52 total sunglasses. How many have regular lenses? 26, which you can reduce, right? 26 over 52 is actually 0.5 or 1/2. So now, if this is going to be independent, I'm going to copy it down. But my given is going to be that they have round frames. So how many total of these sunglasses have round frames? 2. So I'm only looking at this column right now. And out of those 2, how many have regular lenses? Oh, sick. What do you notice? They're the same. Independent. INDEPEN. All right, there's a backside. We got 2 more to go, then I'm done. For number 2? Yeah. No worries. Right? Okay. Bring back those tables. I know you guys are excited about this. We're looking to see, is the event, the outcome is a divisor of 1? And is the event, the outcome is divisible by 5? Are those independent? So let's choose one. Which one do you want to choose?
1.
The first one? A? All right, so remember A, I'm going to highlight it. A says the outcome is a divisor of 1. A divisor of 1. All right? So in terms of looking at these, do you guys know which of these numbers, thanks, sir, 1, 2, 3, 4, 5, are divisors of 1? All of them are divisors of 1? All of them are divisors of 1? No? What? No. Just the numbers on the left, the outcomes. 1, 2, 3, 4, or 5. Of those numbers, which of those are divisors of 1? That 1 can be divided by it. There's one of them. Just one. Just one. Right? 1 divided by 1 is 1. So that one is it. So I'm going to write 0.08. Okay, so now I'm going to find this probability. All right, so here we go. My denominator is the probability of just event B. The outcome is divisible by 5. Which of these numbers, or how many of them, 1, 2, 3, 4, or 5, are divisible by 5? Just 5, right? 5 is divisible by 5. Okay, so that goes in the bottom. Now remember, what goes on top here? Do you remember if you look above Jimenez's head? What goes on top? A and B. So remember I highlighted in yellow for event A and teal or turquoise for event B. Think back to yesterday. A and B would be where they overlap and make green. Did that make green anywhere? No. So if I ask you, what is the probability that the outcome is a divisor of 1 and the outcome is divisible by 5, the answer should be 0. There are no numbers. The probability is 0. And what's 0 divided by 0.04? 0. Interesting. So when I did this condition, my probability went to 0. So these are not independent. And for funsies, these events are actually disjoint. Now, do you need to know that for this link? No, but Alan, you're right. You do need to know that for life, for this class. So they're actually disjoint. Probably too many exclamation points. I'm sorry. Everyone okay with that? So that's one of those. I put this on here because you see that they're not the same, but one of them went to 0, right? It went to 0. So if I tell you one happens and the probability of the other one happening goes to 0, then they're disjoint. Okay, ready? Last one. Which one do you want to choose? Trick question. What do you notice about these events? What up, right? So I'm going to do event A because they're prime. Who's got the prime numbers? 2, 3, 5, and 7. Let's add all those up. So I've got 0.2 plus 0.08 plus 0.36 plus 0.15. Probably easier to add the other ones and subtract from 1 if you'd like. Because that's 9 plus 12 is 21. Subtract, you get 79. Somebody check me on that? Yeah? Somebody checked it? You typed it in? Oh, thank you, Sergio. Appreciate you. 0.79. So now, if this is going to be true, right, my denominator is where I'm going to highlight in blue. But notice that it's the same, right? Outcome B, or event B's outcome is prime, so I'd be highlighting the same things. So all of that is going to go in the bottom, 0.79. And you see how they all turn green? Every single one of them turn green. So what's the probability of A and B? Excuse me. Woo! It's 100%. Oops, sorry. Should be all of them added together. So this is 0.79. And so what happens? Oops, sorry. When you divide those, you get 100%. So our probability change, so they are not independent. And if I tell you if I tell you that the outcome is prime, the likelihood that the outcome is also prime is 100%. That kind of makes sense. They're the same thing. All right. So that's what you should expect to see